let's answer this question. It says if it's an inclined plane, okay, it has three masses suspended, okay, by means of a rope, strings. It says if sin theta equals 1/10, find the acceleration of the masses, assuming they move, and the tensions in the rope. So how to deal with this kind of situation is that, of course, two masses, 10 kg and 2 kg, are connected by means of this rope, and two other masses, 2 kg and 8 kg, are connected by means of another rope. So they will have two tensions. Okay, first let us assume that the direction of motion is here, is towards the 10 kg mass. Okay, that means the weight, there will be a tension. Let's call it T1. The tension in this rope is the same tension with respect to 2 kg. We call it T1. But the tension is not the same if you're considering 2 kg and 8 kg, because the different kind of force will be exerted. And so this tension here is in this direction. We call it T2. And with respect to this, to be in this direction. Okay. Now, the weight of this 10 kg mass will be acting vertically downward. The weight W is mg. That gives us 100 Newton. Okay. Now the weight of this 8 kg mass will be acting vertically downward, which will be W equals mg. That's why G is given as 10 meter per second squared. So that will give us 80 Newton. Now, the weight exerted by this 2 kg mass is inclined, so we resolve it into perpendicular and parallel forces. Of course, what does that mean? It's acting vertically downward. It will act this way, okay? So it will act this way. Now it will be resolved into normal and parallel forces. Okay, so this weight acting this way is a summation of course, this is theta. Okay, these two lines are parallel. This is theta, this is 90 degrees. So here will be 90 minus theta. So here will be 90 minus theta plus 90. So that will be, here will be theta, okay? So here, opposite, here is mg, okay? With respect to this, here is mg cos theta, here is mg tan theta, acting this way, okay? So this is we've been able to resolve this because this is isosceles of hypotenuse, mg, acting this way, so we resolve it. Now, of course, this is normal to this force, to this weight, mass 2 kg, okay? Now, but we may not need it, but let's see. Let's do their force diagram. With respect to the 10 kg mass, the force diagram will look this way. So this is 10 kg. So the weight is 100 Newton. Now the tension is T1. Direction of motion is towards this acceleration, okay? Linear acceleration towards the 10 kg mass. With respect to the 2 kg mass, we will have, this is 2 kg mass. Motion is this way, okay? In this direction. So it goes up with respect to 2 kg. So you have acceleration. Now, you can see this is tension, T2, acting in this direction. There are two forces acting. Look at this mg sin theta. It's also acting in this direction. You have mg sin theta. Mg sin theta is mass is 2 times 10. Recall that sin theta is 1 over 10. So we have 1 over 10. That gives us 10 cancels 10, 2 Newton. So we have here is 2 Newton, okay? Now, T1, tension 1 is acting in this direction. With respect to the 8 kg mass, we'll have this kind of, the force diagram will be, this is 8 kg. The weight is acting vertical downward, so the weight is mg is 80 Newton, okay? We know already. Now, the other one acting this other two is the 2 Newton mass. And again, acceleration is in the opposite direction. Now we take them one by one. With respect to this 10 kg mass, because motion is towards the direction of action of the 100 Newton weight, the net force responsible for the motion is you remove the tension T1 from it. That gives us equal to the mass multiplied by the acceleration. The mass is 10 times the acceleration 10a. So we're having 100 minus T1 equals 10a. That gives us equation 1. Okay, linear acceleration. Now with respect to the 2 kg mass, we have tension because the direction is motion is in the direction of the tension T1. So the net force is the tension. You subtract these two, T2 plus mg sin theta, which is 2 Newton. That gives us mass times acceleration. The mass is 2, acceleration is a. We call it equation 2. With respect to the 8 kg mass, motion is in the direction of T2. So net force, the force responsible for motion, minus 8 equals mg, which is 8, ma, which is 8a. That's equation 3. Okay, now from one, so you can see that T2 here, the same thing as that is 3 is 8a plus 8t. We call this equation 4. Okay, now from one, T1 is 100 minus 10a. We call it equation 5. So we use equations 5 and 4 in 2. Okay, so recall that 2 gives us T1. T1 is 100 minus 10a. T2 is 8a plus 80. See that? Now plus 2 equals 2a. So we're having 100 minus 10a minus 8a minus 82 equals 2a. See that? So we're having 800 minus 82. This is minus 18. 10 plus 8 is 18a equals 2a. So we're having 100 minus 82 is 18. Minus 18a equals 2a. So we now have 18 equals 2a plus 18. That gives us 18 equals 20a. So 20a, so that a becomes 18 over 20. That gives us 0.9 meter per second square. So T1 from equation 5, T1. Let me bring my calculator close. From equation 1, T1 is 100 minus 11 minus 10a. That is 10 times 0.9. That means T1 is 100 minus 9, which is 91 Newton. Then T2 from equation 4 is 8a plus 80, which is 8 times 0.9 plus 8, which is 0.9 times 8, 7.2 plus 80. That gives us 87.2 Newton. Therefore, A equals 0.9 second squared. T1 equals 91 Newton, and T2 equals 87.2 Newton. Thank you very much.